This is a BMW crown wheel that I am machining on a machining center. This is the 135mm PCD, which is the smallest one. They also have 145mm PCD, which is pitch circle diameter for the bolt holes. And then they also have the 152, or is it 154mm PCD? I can't really remember. Anyway, so this is the smallest one, 135 PCD. See that square plate there we just made up? So you can quickly get the center of it with a hole in the middle. We've got a rod that's in a tool holder. Comes straight down, the rod fits in there nice and neat in the center, and then you can record the positions. So then you've got the center of the job. And then you tighten them two nuts up on the top there, which clamps it on the table, because there's all thread going to the T-slots with those two nuts. Just like this, I'll show you. They're going in there with T-slot, T-bolt, whatever, and a nut on top, which is those two nuts there. And that's a 10mm. Look at this big long tool holder I have. Look at that. That big long tool holder. You can machine things that are very close to the table when you got that holder. There's a counterboard. This 10mm M mill. At the moment is doing this counterbore, getting rid of the case hardening, so when you tap it, the tap doesn't fuck up. So at the moment this M mill there is coming down very slowly, and this table is going like this, as you can see up here. See, that's the program, and this is the distance to go. So Z is coming down, so it's coming down very slowly, and X and Y is the table. So Y is back and forward, X is left and right. As you can see up there, Y is back and forward, X is left and right. So X positive's that way, X minus is that way, as you can see there. So it's almost finished that part. So, at the moment, it's doing 1,800 revs, 15 millimeters a minute. See the X, Y, and Z. So it's gonna come up in a sec. Up it comes. Yeah, how does that look? Yeah, that's alright. So next hole. So we just see the hole it's made. So that's the tapping size, which is 10.2, I think, from memory. Let's see. Program. Oh, you can't see it now. Anyway, so it had the tapping size written on the program, but that 10mm M mill comes down 15mm deep and comes out to about 10.2 millimeters. So the table only moves slightly. I think it might be 10.6. 10.6 millimeters is the tapping size for 12 millimeter tap with a 1.25 pitch. I think it's 10.6 millimeters. But anyway, if it's not, doesn't matter. It's doing the right one. It's programmed set to be correct. But yeah, see? So once it goes around and does all these holes, 15mm deep at 10.6 diameter, then the tool will come up, it will get the 12mm spiral tap, 1.25 pitch, come down, tap the holes 14 deep, so the tap doesn't hit the bottom of the hole and explode into pieces, and then it's finished. Then we can bolt it to the quaife LSD, set it up with backlash, correct amount of backlash, which is 4 thou. They come with 4 thou, these BMWs. Other diffs usually have 6 or 8 thou. These BMWs have 4 thou. So I used to get these M mills from Goering up in Clayton on Jack's Road. They sell tools, Goering, and they were like $80, or this is a 10 mil, so this one's like $50 or something, or maybe $70 now, I don't know. But anyway, so instead of buying them from there, I went, because they're carbide M mills, I went on to AliExpress, and you get them direct from China for like $10 each. I think they might be like $16, I don't know. But a big price difference, seeing that you go through like, you know, fucking 10 M mils a week. spindle load. A spindle load, 6, 7%, 8%, 6%, 5%. See that spindle load? That's how much the load is on that tool. So, when you get over about 8%, I've noticed, it's too much and the end mills start wearing out rapidly. But if you keep about under 8%, they last a lot longer. So that's what I've been doing for a while now. Because if you push them too hard, like I could make this go fast as. It's going relatively slow. I could make this go twice as quick. But then you run the risk of blowing the end mill up and having to start again, or making it wear out before it even finishes the job, which is another thing that you don't want to do, because then you have to start again. So you got to get the right feed rate and the right spindle speed, because these crown wheels are made out of very tough material. That's why I'm using a carbide end mill. Carbide's very tough material. If I was using a high speed steel end mill, it wouldn't finish the job. You know, I'll just pause it, and once it finishes doing all these holes, I'll hit play and you can see it doing the tapping. Okay, so we just finished doing all the holes. Let's blow it off and have a look. Right, so the end mill. All the holes. Get this cooling all over my phone. It's a bit silly. That's what the end mill looks like. Now, let's quickly show you another thing. Check out this thing. This is a Raspberry Pi I just got today. Raspberry Pi 3. And I got the board up there. It was $50, Raspberry Pi 3B or 3C Plus or something like that, which is upgraded. So I'm going to undo these 4 screws, take the back off, take out the Raspberry Pi, and then put in the upgraded Raspberry Pi, so it's a bit more powerful. But this thing comes with, like, I don't know, 20,000 games or something. Amazing. Play all the old games I used to play when I was a kid. Anyway, now, so what we should do is probably measure the holes just to make sure that they're the right size. So I'll just pause this. I'll go get a vernier. That'll be close enough. A vernier caliper. Now, how am I going to do all this? Hold the phone and measure. Let's see now. So, we'll put it to metric. Metric. Close enough. Right. Ooh, this is going to be tricky. Ten 10.7. Now let's see what the tapping size is. So if I just stop this, go edit, come up the top. Sorry, you guys can't see. Now what are we going to do? Count the ball 1.5 deep. No. Come down to here. 10mm drill out, tapping size 10.8. Oh, so it is, it's close enough. That'd be 10.8. 10.8. Tapping size, see? 10.8. Right, so we'll come down. We finished doing those holes, so I'll just come down, down, down. Okay, so here is the, we're going 250, 200, okay. I see. 12 by 1.25 pitch tap. So, let's do that. Now, single block, check. We're going to come down 170 mil. Right, so that should be 50 mil above the job. That is way more than 50 mil above the job. Why is it so? 50 mil. Is that'd be way more than 50 mil. Might have this height set incorrect. So that's 50 mil. Yeah, I have it set wrong. So what I have to do is I might have the offsets wrong. So if I come into the offsets, I go offsets, tool 5, 37.8. So 37.8 input. Now let's try again. 0 return. Now, edit. Back up to the tap, which is tool 5. Right. Single block check. Right, so that's supposed to be 50 above the job. Here's 50. And it's not 50 above the job. Let's just see something here. If I go tap 50. Let me just do something quickly. I can't do it with one hand. Right. We're back. Now. So, I just had to set the offset correctly. So, we're going to run the tap. So, start. Take single block off start. Comes in, comes out. Rigid tapping this is. Next hole. Comes in, comes out. Bending over like that. I've got all this technology in my hand. All I have to do is fucking zoom in. You see, if you had the feed rate or the spindle speed wrong, it would just bust the tap because it has to go down and turn at the right speed to get that 1.25 pitch. So right now it's doing, what's it doing? It's doing 250 millimeters a minute and the spindle speed is 200, which is therefore cutting the thread. And also you need to have the hole the right size for the tapping size, which was 10.8. And that's the end of it. And check this out. Get rid of that coolant. Do the tap. That's a Goering tap. There you go, the job's done. Got 10 bolt holes. You gonna focus, mate? You see? All over Rover. That's how you do it the professional way.